At the end of 2015, NASA extended an invitation to journalists to visit the Quantum Artificial Intelligence Laboratory, a collaborative project involving NASA, Google, and the University Space Research Association, situated at NASA's Ames Research Center in Silicon Valley. According to the invitation, media representatives would have the opportunity to capture images of the quantum computer hardware at this facility for the first time. The announcement revealed that Hartmut Nevin, the technical director of Google's Quantum Artificial Intelligence Lab, would participate in a discussion at this event. Previously, Google had only occasionally provided glimpses into its quantum computing efforts over the past few years. Google and NASA first announced their collaborative efforts around quantum computing in May 2013. Initially, this initiative relied on a quantum computer from the startup company D-Wave Systems, but since then, Google has expanded it to include the development of its own quantum chips. However, recent information indicates that this project had to be halted for some reasons related to a decision by the US government. This sudden decision was made after a series of developments that raised questions about the future intersection of artificial intelligence and quantum computing. Will this be a leap forward for technology and science, or a setback for the advancing civilization of humanity? The decision to suspend quantum computers. In recent years, quantum physics and quantum computing systems have achieved notable breakthroughs. However, the superior speed and uncontrollable capabilities of these systems have raised concerns among the public. Quantum computers, the next frontier in computing technology, operate based on the elusive principles of quantum mechanics. Unlike traditional computers that use bits as either 0 or 1, quantum computers operate with qubits, which can exist simultaneously in multiple states due to superposition. This represents a quantum leap in computing power with the potential to revolutionize various fields. NASA's Quantum Computer Project, in collaboration with Google, has made strides in exploring the capabilities of this advanced technology. However, recent events have impeded their cosmic ambitions. The US government has expressed concerns about the rapid development of quantum computing and took an unprecedented step by instructing NASA and Google to shut down their quantum computer projects. This decision has left the scientific community in a state of uncertainty, especially when considering the potential benefits that quantum computers could bring to space exploration, cryptography, and other advanced technology fields. Prominent figures in the scientific community, including Michio Kaku and Elon Musk, have long sounded alarms about the potential dangers of uncontrolled developments in both AI and quantum computing. Michio Kaku, a theoretical physicist, set a record by declaring that the danger of AI surpasses even the threat of nuclear warheads. His concerns revolve around the rapid progress of AI, something he claims has the potential to far exceed what most people realize, with exponential rates of improvement. The decision to halt NASA's quantum computer project raises questions about the interaction between AI and quantum technology. Are there unforeseen consequences or dangers lurking in the field of quantum computing that led to this abrupt cessation? Quantum computers, with their immense computing power, have the capability to break traditional encryption algorithms. This raises concerns about the security of sensitive information, including financial records and confidential data. Furthermore, the implications of exploring space and technological advancements are profound. Quantum computers are expected to play a pivotal role in simulating and modeling astronomical phenomena, optimizing space missions, and enhancing decision-making capabilities in cosmic conflicts. As we navigate through this unexpected twist in the quantum story, it is evident that the cosmic dance between AI and quantum computing is not without risks. The delicate balance between unlocking new realms of computation and safeguarding the digital landscape in our universe remains a universe-spanning challenge. Though the exact nature of what transpired is unclear, what we know for certain is that NASA's quantum computer project is currently on hold, intervened by the US government out of concerns regarding the convergence of AI and quantum computing. The reason is that the advent of quantum computers could mark a historic breakthrough with profound societal impacts and raise concerns about their potential dominance over humanity. The dance between these advanced technologies carries the weight of cosmic implications, adding an element of uncertainty to the future trajectory of AI and quantum computing. The power of quantum computers. However, the story is far from over, and the scientific community, with relentless efforts in pursuit of knowledge and progress, will undoubtedly continue to illuminate the mysteries within the cosmic boundaries. Standing at the crossroads of AI and quantum computing, the journey ahead promises both inspiring discoveries and potential pitfalls, demanding our collective attention and vigilance. Quantum computers, with their superior capabilities, are poised to become a formidable tool in the arsenal of science in this new era. They have the potential to revolutionize various fields and profoundly impact society. However, it is crucial to note that quantum computers are still in the early stages of development and may take some time before they become widely prevalent and deployed. In the future, quantum computers are likely to be used for specialized tasks in areas such as finance, chemistry, and material science, where they can provide significant advantages over classical computers. Furthermore, quantum computers also contribute to accurate weather forecasting and warnings about extreme weather phenomena. This enhances life-saving capabilities and reduces property damage by predicting severe weather conditions and future disasters, enabling timely response planning. In the long run, quantum computers may become more widely prevalent and used for various applications. For example, they could be employed to perform complex simulations and computations in fields such as healthcare, energy, and transportation. There is also the potential for quantum computers to tackle problems that are currently considered highly challenging for classical computers. This can be achieved due to the unique architecture of quantum computers. Classical computers rely on traditional silicon chips using bits that can only hold one of two values, 0 or 1. In contrast, quantum computers use quantum bits or qubits, which can exist in multiple states simultaneously. Qubits rely on quantum phenomena such as superposition, where a particle can exist in many states at once, and entanglement, where the states of distant particles can be linked so that changing one particle will instantly change the other. In theory, this allows qubits to perform computations much faster than classical bits. However, in history, quantum computers have shown a vulnerability. The quantum states of qubits are extremely delicate, and even the slightest disturbance from the external environment can disrupt their states permanently. This makes quantum computers highly error-prone. Nevertheless, a recent study by IBM suggests that these errors can be minimized and quantum computers can be utilized in ways that classical computers cannot. The results of this research have foreshadowed even more opportunities for quantum processors to simulate physical systems far beyond the reach of conventional computers. In the new experiment, the Eagle quantum computer with 127 qubits, using qubits built on superconducting circuits, calculated the complete magnetic state of a two-dimensional solid. Researchers then carefully measured the noise generated by each qubit. It turns out that some factors, such as imperfections in the supercomputer's materials, can reliably predict the noise generated in each qubit. The team then used these predictions to model what the results would be like without that noise. Statements about the potential of quantum technology have emerged before. In 2019, Google scientists claimed that the company's quantum computer, called Sycamore, solved a problem that a classical computer would take 10,000 years to solve in just 200 seconds. However, the problem it solved, essentially generating a huge list of random numbers and then checking their accuracy, has no practical application. On the contrary, IBM's new performance applies to a real-world physics problem, albeit a very simple one. Dario Gil, IBM's senior vice president and director of research, stated, "This is the first time we've seen a quantum computer model accurately a physical system in nature beyond the leading classical methods. For us, This milestone is an important step in demonstrating that today's quantum computers can indeed be used to model extremely hard and perhaps impossible problems for classical systems, signaling that we are entering a new era in quantum computing technology. It highlights a significant leap forward in the capabilities of quantum computers, showcasing their potential to tackle real-world problems that were previously considered extremely challenging or even impossible for classical systems. This achievement opens the door to new possibilities in quantum computing and paves the way for further advancements in the field. The race between the giants. In December 2015, D-Wave Systems, a Canadian quantum computer manufacturer, announced a collaboration with NASA and Google to establish quantum computing laboratories. NASA and Google purchased D-Wave Systems' quantum computer models for tens of millions of dollars. In May 2017, IBM announced the successful development of a 17-qubit quantum computer. In November 2017, the company further revealed the introduction of a prototype version of a 50-qubit quantum computer. In October 2017, Intel also officially announced the production of a 17-qubit quantum chip. Not to be outdone, Google introduced its own 20-qubit quantum computer in June 2017 and aimed to launch a 49-qubit computer by the end of 2017. Despite lagging behind its competitors, Microsoft remains hopeful of developing quantum chips following the topo qubits model, a more stable form of quantum bits. Topo qubits are believed to have better error correction capabilities than conventional quantum bits. Additionally, IBM has made its 5-qubit quantum computer available on the cloud to allow researchers and programmers worldwide to familiarize themselves with quantum programming concepts and rules. Microsoft is also developing a quantum bit programming language, expected to be launched later this year, providing libraries and specific guidance for programmers to acquaint themselves with quantum system programming. D-Wave Systems has released an open-source toolkit for its quantum computer system to help partners and customers easily and quickly develop quantum computing applications. Furthermore, Intel is actively involved in research and development of quantum computers. They introduced a quantum simulation microchip called Tango Lake and are working towards developing an actual quantum computer. At the ongoing Consumer Electronics Show, CES 2018, Intel addressed security vulnerabilities Meltdown and Spectre in its processors. CEO Brian Krzanich affirmed that 90% of Intel processors will receive patch updates by the end of this week, while the remaining ones will be fully addressed by the end of January. Intel stated that Tango Lake is only 1/4 the size of conventional quantum chips, featuring significant improvements in thermal performance, reduced radio frequency interference, and enhanced capabilities to expand signal channels in and out. With 49 qubits, this will be the most powerful quantum chip in the world currently. Intel also mentioned its continued collaboration with Q-Tech to further develop and refine the Tango Lake quantum chip. Despite security concerns, Intel continues to unveil new processing chips at CES 2018. These processors are expected to become the next generation of super-fast processing chips. Threats and risks. Despite bringing immense potential in the field of computing, quantum computers also come with certain risks and concerns. These may be among the primary reasons leading the U.S. government to halt projects that combine artificial intelligence and quantum technology. Firstly, there are security concerns. Quantum computers have the ability to decrypt modern encryption systems significantly faster than traditional computers. This could pose a threat to existing security systems and privacy. The use of quantum computers may impact secure information transmission and cause harm to industries such as banking and insurance. Accompanying this risk is the potential to break algorithms and induce changes in areas like finance and economics. Quantum computers can break existing algorithms and create new ones. This could lead to difficulties in tracking and controlling existing rules and processes in critical areas such as finance and economics. Furthermore, Its complex operational mechanism requires a substantial amount of resources and advanced technology for construction and operation. Developing and maintaining these systems can be costly and demands high expertise in quantum physics and quantum computing. This may limit the practical application of quantum computers in businesses and organizations. Moreover, quantum computers are susceptible to quantum noise and other random errors. This affects the accuracy and reliability of computational results. Addressing this issue is considered a major challenge in the development of quantum computers. Therefore, despite significant progress in quantum computing, there are still many weaknesses and limitations that need to be addressed before quantum computers can be widely deployed. Although there is immense potential and rapid development, the current state of quantum computing is comparable to the early stages of classical computing in the 1950s, when a computer using vacuum tubes occupied an entire room. IBM's current 17-qubit quantum computer has computational speeds inferior to conventional computers. The upcoming official release of IBM's 50-qubit quantum computer is expected to outperform traditional computers in terms of computational speed. The challenge in building large-scale quantum computing systems lies in maintaining the stability of quantum bits, qubits, in a superposition state before they collapse into the basic 0 and 1 values, an extremely difficult task. Currently, all quantum computers have to use specialized cooling systems to keep qubits operating stably at near absolute zero temperatures, 0 K or 273.15 degrees C. IBM's 5-qubit quantum computer only maintains superposition for 47 to 50 microseconds, and the 20-qubit machine can maintain it for only 90 microseconds. Additionally, increasing the number of qubits makes their operation more unstable and prone to errors due to increased uncertainties in measuring states, science, and politics. Nevertheless, the technology race continues and shows no signs of stopping at the borders of any country. Before deciding to temporarily halt quantum computing-related projects, the United States had made a significant investment in this field to directly compete with China in 2020. The U.S. government announced plans to invest $1 billion in multidisciplinary artificial intelligence, AI, research, and establish quantum computing centers, according to the WSJ report. A total of 12 centers will be funded, with each located in different federal government agencies. Researchers at these centers will work on a wide range of projects, from machine learning for ocean and atmospheric sciences to high-energy physics simulations using quantum systems. This investment is part of the White House's plan to boost the development of emerging technologies. Previously, many U.S. advisors expressed concerns that the United States might fall behind countries like China in AI and quantum research. At the same time, experts also issue warnings that these future technologies are not just tools to boost economic development, but are also closely related to national security. It is challenging to clearly determine whether the investments of the United States or China are greater, as these technologies are invested across various sectors. China currently aspires to become the global leader in AI by 2030, although the United States remains the leader in defense budgets, which includes AI research. The Trump administration presented this funding plan as a way to rescue scientific support. During his 4-year term, Trump significantly cut federal research across the board, including critical issues like climate change. Only AI and quantum computing, closely tied to the global military and geopolitical power of the United States, saw increased investment. America must continue to lead the world in AI and quantum. The future of U.S. economic prosperity and national security will be shaped by how we invest, research, develop, and deploy these cutting-edge technologies today. According to the plan, $625 million will be allocated to fund 5 quantum information research centers associated with the U.S. Department of Energy. An investment of $140 million will go into 7 AI initiatives, with 2 overseen by the U.S. Department of Agriculture and 5 overseen by the U.S. National Science Foundation. Private companies such as IBM and Microsoft are reported to contribute $300 million in donations for technology services, likely related to cloud computing. What future will open up? The race continues to expand as McKinsey consultants recently released the report, the 2022 Quantum Technology Monitor, stating that, in 2019, Europe was the world's hub for specialized information and scientific papers on quantum technology. A similar trend is observed in quantum technology companies in Europe, which rely on scientific research results. Currently, Europe has the world's largest quantum technology industry, with around 150 companies and over 100 startups operating in this field. However, these companies are facing challenges in scaling up while dealing with the reality of a lack of investment capital. According to McKinsey's data, considering the amount of investment in quantum technology startups, Europe has only invested $294 million from 2001 to 2021, while the United States leads this list with $264 billion, followed by the UK with $979 million, and Canada in third place with $658 million. The issue of investment and development funding has been addressed. While quantum computers are not yet ready for commercialization, trial models of various quantum technologies, such as quantum sensors, are ready for testing in various applications. An example of the potential application of quantum sensors is in medical diagnosis, where they could be used to zoom in on the scale of each neuron. However, in satellite measurement and positioning, they could also enable precision at the level of centimeters or millimeters. U.S. investors are showing a keen interest in this technology, but according to Enrique Lizaso Olmos, the founder and CEO of Multiverse Computing, they may have strict investment policies and may have many limitations, such as not allowing investments in certain European countries. Additionally, Europe will provide quantum technology companies with opportunities to place bets on new applications within the framework of the quantum technology testbeds of Horizon Europe. This is a multi-million-euro project, and the European Commission is selecting companies that will receive investment budgets and access to infrastructure, according to information from the European Commission. Europe is also encouraging member countries to increase national investments in quantum technology. However, despite the initiatives from Europe and some member states, industry professionals and scientists still believe that the most crucial aspect is to eliminate legal constraints that make it difficult for startups to access investment programs, causing a boom in startup ecosystems. Similarly, constraints on measures ensured by governments should be considered specifically for quantum technology, providing incentives for this field. Lizaso proposes that Europe must have the capability to become a leading investor in venture capital, similar to the case in Canada. Lizaso suggests that the threshold for quantum companies in the EIC Accelerator program should reach €50 million. At the same time, improvements need to be implemented faster due to the terrifying pace of change in specialized technology fields. At the national level, Calarco proposes the creation of a comprehensive structure for quantum technology, with the participation of all ministries allowing budget allocation and policy frameworks to be enforced. Collaborative efforts among member states are also crucial. EICL states that national efforts must be coordinated and implemented at the EU level, allowing venture capitalists to form large organizations and work on a larger scale. Finally, when you look at the challenging journey of the collaboration project between NASA, Google, and the Space Research Association, it's not just a technological endeavor, but also a journey of understanding and exploration. However, challenges are inevitable, and the decision to halt the project marks a significant turning point. This is not just an interruption in the space technology race, but also an opportunity to question the future intersection of artificial intelligence and quantum computing. The abrupt cessation of the project poses a significant challenge and raises important questions about the direction of technology and science development. Will this event be a leap forward, bringing about significant innovations? Or is it an unforeseen end to an essential part of contemporary civilization? We stand at the signs of a revolution, and together we will continue to monitor and explore new directions in the future of technology and science. Don't forget to subscribe to stay updated on the latest developments and discoveries in the challenging world of artificial intelligence and quantum computing.